So next talk is on enhancing MVC architecture pattern description using its system of systems model.
My name is Mrityunjay. I'm here to talk about a topic which seems mouthful, so I'll try to break it into pieces and I'll talk about what we are talking about here. It is a part of a bigger plan, bigger story that is there, and I'll start with the story and then we'll get of what the paper has. And so just to be clear, my positionality is to be different. This is a very biased view. I have enough time in the industry, so lots of things that I'll be talking about here could be very biased. Take it with that pinch of salt. I have tried to solve for it. I may not have. Of course, many of the things that we are talking about here in India, there are lots of colleges. I come from a certain kind of college, and therefore I do represent other colleges, even though my hope is whatever we are talking in terms of solutions, they are applicable everywhere. So we'll see how that goes. And so keep this in mind as we go through this, because I'm also talking about my overall work. So one slide summary of what I am trying to talk about here is we have architectural patterns. There are design patterns, architecture patterns. We expect a developer, as soon as they come into the industry, they should know all the design patterns. I'm saying they should know architecture patterns as well. My experience has been they don't know that well. And so one of the idea was, okay, look at the descriptions, see are they good enough for freshers? If I do hand over to them and say, boss, go read all of these patterns and then be knowledgeable in 10 days, 15 days, can they do that almost immediately? Answer was not really, because it was hard for me to find even the standard benchmark description of a given particular pattern. And so that's where it started. And then we said, okay, there is a way in which we can improve them. There is the way that we are proposing in our overall broader research, and that also became part of this paper. So that's what we focused on. And so the larger stories, I did want to tell the larger stories. The larger story is, overall when you look at, that is my PhD research problem, industry is very focused on certain kinds of ways in which the work happens. And whereas if you look at what people get taught, essentially the focus is on creation. Create software, design, architecture, and of course, lots of programming. Whereas when you go to industry, almost the first activity you are asked to do is, hey, here is my software, 10 million lines of code, understand it, 1 month later, 2 months later, start doing your bug fix. So you are evolving, you are not creating. And so that becomes the first dichotomy that this poor fresher faces. And again, my context is SaaS product companies. I believe it is all product companies, all complex software companies, not necessarily product companies, but at least my context is SaaS product company. So that's one part of the problem. So here is one individual coming out of college, gets into this problem, comprehension versus creation. But that's not all. There's other kind of problem, which I feel is a bigger problem. They do not get exposed to complex systems, which most products are. Most products are. And when I say complex system, really it is systems which are composed of other systems. And I'll talk about what it means. But in general, their focus has been on programs, algorithms, now these days competitive programming, and really focusing on solving the logic and just going into a piece and go deep. Not necessarily a software which is actually solving something of value for some stakeholder out there who doesn't care about your software, who cares about the value you get. And so that's the difference. And systems do that. And complex systems, of course, have their complex, and they never get exposed to it. And that creates problem. And we'll see what kind of problem. And essentially what it means is comprehending complex systems is required in industry. And almost the first task is comprehend a complex software. I mean, I work in a company called Zenoti. It's a unicorn and all the big good stuff. Very complex piece of software. It's an all-in-one software for managing large chain of salons of 5,000, 10,000 centers. I ask these guys, you have 6 weeks to understand it enough to do your first change in production. They try, of course, they can't do much. So it's a missing skill. And that's what the statement is, it's a missing skill. And so that led to the art that we have in this paper, which is a small part of overall work, to say, okay, I can hand over and I can expect these guys to understand architecture pattern, because SaaS products go through infrastructurally, have very straightforward set of architectural patterns that they use. So if they already knew it, or they can know it quickly, at least some part is product specific is what they need to learn, and my other part of the research is around how do they learn those part as well through some generic skills. But that's where we started out. The first question was, so what is that benchmark? So I started with one simple example of MVC. I could have taken any other one also. but MVC is supposed to be simple, supposed to be used all the time, and therefore that was the starting point. And so, which source? So there are lots of books, lots of things. So what was it? That's where it started. Then, is it fit for the need for novice engineers? So that was the idea. And again, what does it mean to be a fit is what I think 30% of the okay, how do we define some of those things? And then finally, if it is not fit, then what can be a fit? How do we extend it to make it better for people? And that was the idea. So architecture patterns, again, I'll skip over it, but essentially that is the idea that you have architectural problem, you have a pattern that you can solve again and again, and people can use it. Right? So for example, MVC pattern is there because the problem space is about data safety. You want to make sure all kinds of interfaces are possible, mobile interfaces, web interfaces, phone interfaces, watch interfaces. You want to change very quickly all of your user interfaces. How do you do that? MVC offers you that solution by separating the concern, presentation is separate, controls are separate, data is centralized through a model, and those good stuff that comes through design decisions. Now, you would want people to understand this. And the typical source of understanding is you can go ahead and read the documentation that is there for the description, right? And again, the Wikipedia gives you that nice picture about how the components, essentially view, controller, and model, are the three parts in which it gets broken. This is just the sequence diagram. One way of showing what MVC really does for you. But if you go ahead and start looking at where to look at least based on some of the evaluation criteria, you can read the paper about what kind of criteria I picked and why. I picked up and said that the book that is there, The System of Patterns by Bushman and co. I think good enough, and again, not so good, but good enough is what I selected and said, okay, this is the benchmark. Let me go start evaluating this one. And so when I started looking at it, and I also did lots of literature around, okay, what should the architectural description have? And so there is remarkably good description early on. I mean, these are like 96, 97, 2000, those times. Lots of things were written around, okay, what should the description have? And so when I look at all of those, I have some criteria, but at least even if I don't look at those criteria, as I started reading, I realized that this cannot be, I cannot hand it over to a novice engineer and say, boss, start reading all these details around the code that is there. The class diagrams are very implementation. If you don't understand implementation, it's very hard for you to figure out. For example, in this case, there's an observer somewhere, but it's not very visible that there is an observer there which will push out all the details. So it just becomes very hard to expect that somebody who comes out of a tier 2 college or a tier 3 college, even a tier 1 college, they haven't really studied it in that focus, and suddenly you ask them that in 10, 15 days understand this, it will be very hard for them. So overall, the conclusion was that it really requires some effort. And so can we do better? So these were the attributes. Again, I'll not go into details. So I was looking at the quality as well as the fitment in terms of the target, the stakeholders, where I am interested in, and in general, the quality definition about clarity and precision. So overall, then the question was, what do we do? And so then this came from our overall work that we are doing in around system and getting people to think in a systems way. And they said, okay, fine, let's look at, because we can look at software pieces as systems, like we look at science pieces, everything around us is a system. So we started looking at it that way. And that is what we want to use as our description of pattern, and hope is, again, I have not tested it yet, the hope is that this is what will be easy for people because this will have a model inside it. And so again, so just for everybody, I'll just quickly run through it, but essentially when we system, we literally are talking about the systems that we were studying in school, or we see systems around us. It's just that we want to break it down into pieces which are much more amenable to software parts of it. So for example, here, if you look at it, entities, interactions, behavior applies to everything. How does it apply to software is what we want to do, and that is the work that we have been up to. And so what we want to really say is systems are systems, whether it is software systems, whether it is your mobile app, whether it's your Pulley, whether it's your Spring, everything. Can I describe them in a similar, consistent way so that when I teach these guys in college, the same thing they can apply to Zenoti's product or a Microsoft product or any other product that is out there, learn in a way is the idea. So what we do, and again, last year in ISEC also I talked about transition systems, but in general, the goal is take a modeling technique. We have taken transition system as a model, which we will apply, and it has these 6 components. Again, I'll not go. I'll show what it means. And essentially, it's a light bulb system. 6 components. You define the states. You define your actions. You define what your observations are. What are your transition functions, which will take you from one state to another state. Essentially, you think in terms of states and transitions. I mean, that's the easy way. And what we do in a system of system notion is to say, extend that further and say, okay, it's too complex to think of the whole thing as a system. We think in terms of components, but each component is a system. It means each component has those 6 pieces, and so therefore you figure out those interactions and all of those for individuals, but then also think in terms of the systems, how they are interacting with each other. So this diagram has been drawn in a certain specific manner. And so one of the things that we want to do is to say that when we define some of these things, we will use diagrammatic notation because it's easier for people, but then we'll have diagrammatic, we'll have mathematical, we'll have programmatic. All 3 should be internally consistent, so you can choose. So if I teach you for 2 days, hopefully you can just use the diagram. You'll be good for some things. If I teach you for 2 weeks, maybe you can do the mathematical notation. If I teach you for the semester, you can use Alloy or Forge to actually start writing some of these things there so that you can do other reasoning and other explorations and other things. But incrementally, you can get. Right? So again, much of the detail is in the paper, so I will not go here more detail. But essentially, the idea is that each of them is also a system. They come together as a system. So the whole thing is also a system, but then the whole thing is composed of 3 pieces. One is a set of systems, the other is a set of channels, communication channel. And then there is a bunch of specific behaviors that will be defined in a certain manner. Right? So then what we did was we took MVC and said, okay, there are 3 components, and there are observers of 4 components. Let's start modeling it. And so half of the paper is actually doing the mathematical description of those models. And go there and read details, but essentially the idea is we start from this, in a way that this picture is a good picture to start from the Wikipedia picture, but essentially expand that into systems, the connections, and again connections come because there is a certain way in which, and again that's the definition of the pattern, there is a certain way these systems will come together and a certain way in which the messaging happen to get you the behavior that an MVC has, because I can take the same boxes, connect them in slightly different ways, or change the messaging sequences, and you will get a very different pattern. Right? So how do you capture those details in a very, very clear way so that the individual knows that, yes, I understand the structure, I understand the connections, and I understand the behavior. Of course, the behavior could be probably more visually written, and that's what we are working on to say, okay, visually also can I show behavior? Right now it looks more mathematical and may put people off, but the idea is that between these 3 components, you should be able to capture the entire detail, in this case of MVC, but in general for any system. And that's what we are applying in other parts in our research. Overall, as I said, the way it is, you have these pieces, they are essentially building the description in pieces, and each piece is clear. And now we have to want dynamics and say, you know what, for example, the picture, I'm not sure if you noticed, there is no connection between controller and model in terms of getting the data. So there's no data that comes. If there's an update, for example, that data doesn't get to controller because controller doesn't need to do anything with it. Let's say controller does need to do anything with it. For example, you show a button, but now you don't show the button because of some reason, because some updates happened, which means controller needs to get the data. Now it doesn't get here. How do I make the change? So again, hope is if you show it in very clearly, here are the components, here are the interconnections, here are the behavior, then you know exactly what needs to change when you say, oh, my requirement have changed, now controller should get data updates. Now you go to the picture, you start figuring out, oh, the behavior has to change in this way, the lines have to be like this, the channels have to be this, and so on. So the expectation is that it's clear in that sense. And transition system model, and again, last year also I talked about this in ISEC, that we have tested this out. Transition system model seemed to be simple enough, at least in the classroom course, for people to get a hang of it. It's not like it's very difficult for them to pick up. So that is the hope, that once we start using it for other purposes like these, it will still be amenable to their understanding. And that, again, we have not tested the ground, but that's the plan. So overall, coming back, the research question, these 3 questions. First one was, the POSA book is probably the best source of documentation. I was really surprised from an industry perspective. There is no such standard catalog where I could go and say, this is the standard definition. I mean, we should have. Benchmark, not really. I think can extend it through system of systems model, which is what we have been talking about. The paper has all the details. We don't have too much detail here. We have tried to do it in classrooms. So I have been teaching, I have been teaching this course in IIIT, where we use some of these techniques and start looking at how do we expose some of these ideas to people so that we can give them a flavor of complex systems which they will go hit in the industry, but then try to do it in the classroom. Seems to work. Again, we have done very small cohorts. The goal is, as we go forward, do it with larger cohorts. And of course, we want to formalize some of the notation and also simplify. Because one of the things I'm doing, and at least my PhD goal is, I should be able to go to a company which has hired freshers 1 month ago, do maybe a 1-week course with them, and give them some incremental value, which they can then apply to the product that they're trying to understand, and maybe cut 10 days, 20 days, 50 days from their onboarding effort that they are doing in terms of understanding the product. So we are trying to separate it out into diagrammatic, mathematical, and programmatic, and people will pick whatever they can pick given the time they have. So I'm done, but please read the paper because this was not doing justice at all to the paper. Paper has much more details, but I'm ready for questions.
Hello. Thank you, Mrityunjay. Very interesting work. I think you are doing the right thing in trying to formalize the notions of software architecture. But my question is about software architecture itself. See, even after 3 decades after Shaw's and Garland's book, right? I think the software architecture books keep getting fatter and more difficult to read. Somehow, everyone seems to agree that software architecture is central to good software development, but we still do not really understand what it is. Do you not think that trying to mathematize it is premature at this stage?
So, no, that's a great point, and that is one Venkatesh and I have been like sort of pushing back and forth. He comes from a different side, I come from a different side. I think at least my view into reading the literature and reading these books, it's almost like there are 2 parts to what work is being done in architecture. There's a whole set of people who are doing lots of theoretical work, including all the formal verification, new languages. I mean, I started looking at, okay, which language should I pick? And I started looking, it became like there are hundreds of languages. I said, okay, I'll not pick any language. Because it was so scary, okay, which one I pick? Other 99 guys will tell me, hey, mine is better. So there is a whole side where there lots of work has been done on the theoretical side, but you're right that on the other side, there is a whole practitioner's work which almost sort of says, fine, wo kuch nahi hai, this is something else. So it's almost like it has become this way. And I, coming from industry, I'm totally cognizant of the fact that, and I have talked to people, my managers, individuals that I have interviewed outside my company, the freshers, nobody wants to see a single line where I say, okay, there is an X, there is a subscript. A subscript is the first point where I say, ye math hai, ye nahi hai software engineering. Where is my code? Right? So I'm very cognizant. So therefore, the goal is to sort of do it slowly and almost sneak it in. At least my hope, people will see something in a day, they will see some value, say, it's very interesting, can you give me more value? I mean, I was really, listening to what you were talking, and at least to me, it felt like, man, this will give me so much value. I'm willing to put that effort to do something more. And so then I can sneak in and say, okay, to do something more, you have to learn like this small piece. Looks like very much like program. Why don't you write this program? Okay, yeah, looks like I'll write this program. Oh, well, looks interesting. Now it can do this. It can reason for me, small piece. So sort of Trojan horse is what my hope is. And since I still look at myself as an industry guy, so I will go back and start sort of trying it out and seeing, is this hypothesis correct, that if I give them value immediately, and then see if something more can come. Can some people at least be willing? And ultimately, it should be a movement, if at all. It will not come from top down. Everybody has to do this documentation and all this. No, nobody will do it. Right? So it will be slow, but hope is that they will go do it. And maths or anything will come, or formalism will come if they see immediate value. They don't see immediate value. I also didn't see immediate value. That's the reason why for the last 4 years I have been pushing Venkatesh back on, I don't want to do this. It's only more recently where I have been sort of a convert of, yeah, the formal way is the right way, and I can figure out how to give that value.
Any other questions?
I mean, for what runs, okay, when I'm an engineer, right, in the industry, I want to deliver code which runs and shows those displays and other things, right?
Right.
So, I mean, whole attention goes there. And then all this aesthetics, performance, they get pushed to the later stages or they get sidelined. Okay. So, so I mean, how it is, so people are good at going towards new technologies, the buzzwords which comes out, LLM has come out, right? They're willing to try it. Okay. Because it's sort of, because they have not comprehended it yet. Okay. Programming, everybody feels they can go and write a program.
Right.
So how to introduce that one step in between so that they can take a pause, think about it, and go to that next step?
Yeah, no, good point. And I think that's the reality. I'll give you a couple of sort of anecdotal things. One, so I run the payments division in my company. Now I'm on sabbatical, but I was doing that for the last 4 years. So one of the things in payment, for example, is one is compliance. The other part is if there's a bug is really dollars. And we have had situations where people would go fix the bug only to figure out 1 month later that we lost $40,000 in Canada because some of the scenario didn't get covered and money was with the customer. So in these cases, for example, the developer was very, very clear after that point, I have to do something. I didn't realize that there was actually a job also running which was doing certain things, and I went ahead and fixed my bug. So when they get into that situation, they are much more amenable to, okay, can I do something else which will help in this situation? Because what they know today is, okay, I can read code, I can read more code, I can write code, I can write more code. Is maybe I can show them that, oh, in this case, for example, in this case, what we started doing then was started doing the mapping. Unfortunately, we didn't have any documentation to say what is the life cycle of a payment that happens, including all these anomalous behaviors that are there. Task will come, job will come, message will come from provider, all kinds of things. So we started mapping that out to say, okay, let's understand this better. Just code will not give you that understanding.
I think the problem is it should be done top down because senior folks, they know they have burned their hands and they can really go and do things well right from the beginning, okay, because they have experienced it. So they don't end up writing documentation.
Yeah, but
they don't end up following patterns, and then they goes to the junior folks who are expected to do that. So
yeah,
it's kind of
but I don't think that is going to happen. I mean, I have been that path. I will tell you that if I am that senior person, even though I'm telling all these things, I am not going to do it because I have better things to do with my time to make more money for the company. Because there are other things. I think, and that's where I kept saying that academia and the people sitting in this room have to take that responsibility that when the individual is going in, they are going in with such high values and high things that they can do and they can show value quickly through things that they have in their hand, that the senior may say, I don't care, good stuff, keep doing whatever you are doing. Or they will say, you are doing amazing stuff here. My manager is saying, I'll fire you and get this new guy in your position. Teach me what you are doing. I think that is the only, I don't think the whole stack of engineers, the manager and CEO will change and say, Acha, kal se na, I will start writing my documentation in Alloy. Nahi hoga. We shouldn't even think about it. I kept being asked was, okay, why don't we take this to individuals and say companies will draw these models and all because I'm doing this for big products. So why can't they do it? It's again not going to happen because again, I have better use of my time than maintaining a documentation. But the individual who is coming in has the incentive to show that, hey, I'm running this product in 2 months instead of 5 months. So they will put the effort. So this is like a personal productivity tool. You can apply all these things, be better. If you are so better, somebody will come and ask you, please teach me. They will teach. Hopefully some movement will start.
It's slightly complicated.
It is complicated. Again, it is messy. But I think all solving problem is messy. Again, my experience, probably, again, I told you my positionality statement, so I can say anything I want. I read lots of papers around computer science education, software engineering, all of this. At least my takeaway was, either I will publish paper or I will do some work. Because I can do very incremental work and get a paper. But then when I'm doing these other messy stuff, I don't know which paper to write because people will say, kya yaar, tum to apne marzi ka hi kuch bol rahe ho. Or then becomes hard. So it's a messy thing, but I think these messy things are what are worth solving, I feel, and we should solve some of these problems. And even if we do an iota, one little change, I think that will be a great thing to do. Sorry, it became a rant. Any other question? Yeah.
I don't know. I mean, I think it's very interesting, first of all. And I agree with you that it is sort of value-driven. I mean, it should be looked upon as a value-driven. But kind of the question or comment I had was, the example which you gave about what really is happening in the transaction and what did the developer miss, and hopefully this should be able to solve it. Now, should that be called as architecture, okay, or architecture pattern? And maybe, you know, you can say that, well, it need not be called architecture pattern, it can be called a business rule or whatever it can be called. So, and it goes back to a little bit of what Sujit was asking. I mean, while you're trying to create a formal representation, is it formal enough? Or do you know, are you trying to create some definitions of what should get captured in what you called as architecture patterns? And unless, as you rightly pointed out, the programmer or developer or designer sees a value in it, he's not going to use it. And in order to bring that value in, you know, the question I had was, are you really trying to create a very formal definition of it? And maybe it can be expressed in a natural language, which is what most developers or maybe domain analysts would be interested in. How formal would that be? Or you know, even though you express it in natural language, is that what we are trying to get at, or are you trying to get at the models that you tried to describe as an example? I'll go through your paper, but I thought I'll just listen to your comments.
No. Thanks for asking that. One, my view is I'm looking at all of these things from the perspective of comprehension. I am not looking at it from creation. For example, if you look at software architecture, most of the time it gets taught from the perspective of, okay, I have to create this big software and therefore you should know architecture just like, you know, design. So as I said, the whole thing about teaching is we teach creation. I am taking a different route. So when I said description, I was looking at description in terms of, okay, is something, software is out there, can I understand it better by understanding the pattern better? The goal was not that it will get augmented in such a way that if somebody is creating, let's say, a next payment stack and then they use MVC and they will read this, they'll know exactly what to do. Maybe they will, but at least I have no such claim. This is very limited to comprehension is the primary problem that I'm trying to solve. Other part is, I think good thing is there is a healthy tension between me and my advisor because both of us come from two different sides. I don't want to do anything that he's doing. He doesn't want to do anything I am doing. So jokes aside, he's formal side, I am industry. And so I think we are very, very cognizant, as I said, of no, don't do formalism unless it's absolutely essential. I told you, like, it took me 3 years to come to a point where I said, yes, some formal thing is good. But that particular language, Alloy, seems good. Alloy seems to be something I can actually write my product, my appointment booking in Zenoti, in Alloy, and I can actually write it in 3 days. And it looks like a program, and it acts like a program, and it still gives me the value. So I see the value. So that tension is there. We do want to create something which doesn't have waste, which Dheeraj was saying, because if we create something, I will add, which is totally formal, everything, I will have that 100 languages, ek usme ek aur 100 first will come in. It will sit, legacy of whatever, the waste of the time, whatever, it will just be there. So that goal is to keep it as practical as possible, and therefore, when you read the paper, do provide that feedback on, you know what, ye bhi aise hi hai, people will not take it. I know developers, they will not take it. So I would want to go change it. I'll go. So we are trying to make it simpler and simpler, and that iteration is going on.
Thank you for the questions, and thank you, Mr.
He has a
Mrityunjay.
question.
Okay, we can take one more question.
So you were talking about implementing some value in the first few weeks when a fresher joins, right? And you started with the problem of comprehension versus creation. So why don't we focus more on bringing comprehension in the college itself? Because there they have more time.
Yes.
And
Yes, no, exactly. No, I think, and that's exactly the hope is. It's just that it will take time, right? It will take time to change curriculum. It will take time. It's a full course. Nobody
why
comes.
don't industry come to help there, in the sense bring more open source projects, like big projects or so on, and try to help some way so that in the last years of academia, the BTech people, or they kind of get exposed to these big projects. And
Again, so that's a great point, and that's what many people are trying to do, including IICT and everybody else, and I have a very different point of view there. It's not academia ke liye, industry is the panacea. Any random guy you pick from industry, put him in academia, and then academia will change to better. it's much more, as he said, it's a much more messy problem, much more complicated problem. So, but the idea is right, that can we push some of these things into our curriculum to say, if comprehension, evolution of software is the order of things, why don't we give it proportionate weight here? For example, ACM curriculum, if you look at ACM curriculum of software engineering, about 80% is focused on creation. 15-20% is, in terms of hours that they allocate, is evolution, and maybe that's what we do in the academia, and clearly that is not enough. So can we go change that? So we'll change that, but I don't think just bringing industry people here and get it changed. Some part may change, but largely it is still an academic problem. Academia has to come back and say, here is the way we'll do it, because they have to also take care of 50 years. I mean, Gen AI comes along and you will start saying, oh, job nahi hai, kal somebody was saying, right? The jobs are going away, right? Academia has to take that responsibility and say, no, job is there because I'm teaching you more fundamental thing. AI will come and go, something else will come. You become the guy who create models, right? You create models, code chala jayega, farak nahi padta. Right? So that's what academia has to take this problem. Industry will be add-on. Or people should come in, stay here, do PhD, learn more, become academic, and then do something. Anyway, thanks. I've taken lots of time.
Yeah, thank you, Mr. Mrityunjay.